Okay, this is Chapter 5, Lesson 5. This lesson is all about simplifying algebraic expressions. This is the core of Chapter 5 right here. And first, we are going to start off with some important vocabulary. So, vocab in this lesson is extremely important. We're going to review it a lot. Our first word is term or terms. And a term is a number, a variable, or the combination of a number and a variable. Okay? And that combination would look like this, 3x or 5y. Terms are separated by our plus and minus signs. So that's how we can find them in an algebraic expression. Kind of use those plus signs and minus signs to break the problem into terms. So next we've got like terms. Like terms are terms that have the exact same variable parts. Exact same. So 3x and 6x would be like terms because they have the same variables. 3x squared and 6x would not be like terms because even though they have an x here, this one is an x squared, which means something slightly different. The next word is coefficient. 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 The prefix co tells us that we've got two things going on here. It's a number working with a variable, and the coefficient is the number part of the variable term. So if I'm looking at these two terms here, the coefficient of this term is 3, and the coefficient of this term is 6. It's the number in front of the variable, okay? So it's not the variable itself, it's just that number piece that works with the variable to create the term. Last word is constant, and a constant is a number term that has no variable part. So neither one of these are constants. A constant would have to look like this, 7. No variable piece at the end, it's just a regular whole number that you'd be familiar with from earlier chapters. Okay, so that's what a constant is. Definitely make flashcards for these guys. You need to study. 7th graders tend to get coefficients and constants mixed up a lot. So you should study these and make sure you truly understand them because we're going to be doing a lot of questions like these example problems on quizzes and tests, study guides. So our first example here says to identify the terms, like terms, coefficients, and the constants in the expression below. Okay, so remember when I said to you that a term is a number or a variable or the combination of a number and a variable? So they're separated by these plus signs and minus signs. That's kind of the way you can find your terms in a problem. Right? So those plus signs and minus signs break the expression into those terms. So when I'm talking about my terms, I do have to look there. I also have to be mindful of the sign in front of it. So we'll talk about that. Our terms are 18m, and I'm going to put a comma there, 8d, and so far those two were positive terms. But this guy here, that minus sign gets pushed with that term to make it a negative 9d. This minus sign gets pushed with the m to make it a negative m, and this minus sign gets pushed with that 11 to make it a negative 11. Okay, so like terms, remember we talked about like terms, they have the same exact variables. So my like terms are, we'll start here, 18m and negative m. I have another set of like terms, change colors for them. I've got 8d and negative 9d. So those are my like terms. Notice I'm changing colors here. What you can do in yours is you can be sure to put and signs with your like terms and put commas between the different sets of like terms. Right? Coefficients. Coefficients are the numbers that are in front of my variable terms. So I'm looking here, 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 and not at this guy right now. That doesn't have a variable, so I'm not worried about that when I'm talking about coefficients. Okay, so the coefficient of the first term is a positive 18. The second term is a positive 8. The third term is a negative 9. Remember that sign goes with your term, so it's going to go with your coefficient as well. And this one gets people, they get stuck. A lot of 7th graders say that the coefficient here is negative m. Well, no, remember m is a variable, not a coefficient. But here we get to bring back one of our properties from 5.3. The property we're going to bring back is the multiplicative identity property. We can put a 1 there. And that 1 does not change the value of the term. 1 times anything keeps that term exactly the same. So the coefficient here is actually a negative 1. Even though we can't see it, that's what it is. Okay? Last part of this example, it's asking us for the constants. Remember, a constant is a term with no variable, and the only term with no variable is this one, negative 11. So that is our only constant in that whole expression. Okay, let's talk about a couple more notes here. Some notes in 5.5. We can only add and subtract terms if they are like terms. That's a really important note. Make sure you put a star next to that. We can only add and subtract terms if they are like terms. We're going to add and subtract like terms very, very soon. Another note that you want to make is that all constants are like terms. And this is kind of by default because they have no variables. So remember, like terms have the same variables, but if there are no variables at all, they're still technically like terms with each other, with other constants. So that's a term you want to make sure you understand as well. Let's do one more example where we have to identify those important parts. We'll go a little faster this time. So the terms, remember, they're separated by the positive and negative signs, even though those signs themselves get stuck with the term, but they do help us to find them. So we'll start here. Our first term is negative 12f. Then we have negative 8b, negative 3b, positive f, positive 6, negative 9. So those are all the terms in this algebraic expression here. Our like terms, I'm going to start with the f terms, right? So that's negative 12f and positive f. So that's one set of like terms. Another set of like terms are my b terms. Negative 8b. Trying to change colors there, it's not working on me. Negative 8b, negative 3b, and I have another set of like terms. That other set is right here, my constants. Positive 6 and negative 9. So remember that note that said constants are like terms with each other by default because they don't have variables. Okay, coefficients. So the coefficients are only, we only have coefficients when it comes to terms that have variables in them. So my first term here is negative 12f, so my coefficient is negative 12. My next term has a coefficient because it has a variable in it. That's negative 8. This term has a coefficient because it's got a variable, so the number in front is the coefficient, negative 3. This term here, I can use my multiplicative identity property to put a 1 there, so the coefficient of that term is a positive 1. These two do not have coefficients because they don't have variables. That means they're constants. So my constants are 6 and negative 9. Example 3 asks us to simplify this expression. So simplifying the expression, the first thing I want to do is I want to rewrite my problem with my like terms next to each other. So here I'm starting off with this long list of terms. I'm going to rewrite it so that I've got my like terms together. So negative 12f plus 1f. You can leave the 1 there, you can drop it, doesn't really matter. Minus 8b minus 3b plus 6 minus 9. So all I did here was I used my commutative property and I regrouped this problem so that the like terms are next to each other. And now I can go ahead and I can simplify this expression. So negative 12f plus 1f, sometimes that gives some kids a hard time. Just think of it as negative 12 plus 1 to get started. Negative 12 plus 1, there's more negatives than positives, so we're going to get a negative. We're going to make 0 pairs, so we're subtracting, and we get negative 11. Don't forget your f. Next, we can do the b terms, negative 8b minus 3b. We're going to add a line, change the sign. Negative 8b plus negative 3b is negative 11b. And last but not least, positive 6 minus 9. We're going to add a line, change the sign, and we get negative 3. And this is as simplified as we can go because we do not have any like terms. So you know you're finished when you have no more like terms to add or subtract together. Last example here, this is a pretty neat one. Maria is a wedding planner. She charges a planning fee of $150. She also provides the following options. So we've got a whole bunch of options here. Maria is planning a wedding with G guests sitting at T tables. Her client has chosen to serve dinner, dessert, and drinks. So that's soda and iced tea, but no linen napkins. She's also chosen to use linen tablecloths and floral centerpieces, but no wedding favors. So that's what she has chosen. Write and simplify an expression to represent the total cost of the event. So starting at the top, the first thing we have to do is pay for Maria. We have to pay for her services, so we have to pay that $150. We're also going to pay $15 per guest for dinner. So that's where that variable G is coming from. $15 per guest for dinner. We're going to pay for $4 per guest for dessert. We're going to pay for drinks, $2 per guest. We're also going to pay for centerpieces, but our variable is going to change here because we're paying $25 per table now. Not per guest, per table. And linen tablecloths are $5 per table. So, big long expression here that we can simplify a little bit. 150 is a constant. No like terms matching up with that constant this time. Then we have 15G plus 4G plus 2G. They're all like terms. And we add them up to get 21G. And 25T plus 5T, they're like terms, and we can add them up to get 30T. That's as simplified as we can go because we have no more like terms. The last thing we can do here is to use our expression to find the total cost if there are 175 guests sitting at 15 tables. So check this out, guys. 150 plus 21 times the number of guests, which is 175, plus 30 times the number of tables, which is 15. And we can do some algebra. We can finish this problem right up. 150 plus 21 times 175. I'm going to use my calculator here, make this a little bit faster for us. So 21 times 175 is 3,675. Wow, that's a lot of money, huh? 3,675 plus 30 times 15 is 450. And if we add all those together, 150 plus 3,675 plus 450 is $4,275. That's a lot of money to spend on that wedding service. All right, so you can see where algebra is really useful. Those like terms, we're going to do lots more of these in class tomorrow. Go ahead and do your practice problems and bring any questions you have tomorrow to class.